So today we're talking about rates, ratios, and proportions. This is just a more basic version of conversion factors and dimension analysis. So it's going to feel like kind of review for a minute, but that's okay. So let's just go back to the basics. A ratio is a comparison of two quantities by division. So the ratio of A to B can be written as that A with a colon B, or A divided by B. And you've got to put where B does not equal 0, because when anything is on the bottom or being divided by, if the denominator equals 0, then it's undefined. So a proportion is a statement that two ratios are equivalent. So the difference between a ratio and a proportion is that this is just the fraction. This is two fractions that are equal to each other. So a real basic two fractions that are equal to each other is 1/2 is equal to 2/4. So that's a proportion. All right. You can use ratios and proportions in dimensional analysis to solve problems. Okay. So here it would be a good example of the type of problem you can use the ratios and proportions to solve. So if the ratio of faculty members to students at a college is 1 to 15, there are 675 students. How many faculty members are there? Okay, because faculty members came before students, it's 1 faculty member to 15 students. Okay, that's how this is read. All right, so how many faculty members are there if there are 675 students? Well, the first thing we need to do is set up the conversion factor. All right, so right there is what they give us. That is our conversion factor, our faculty to students, 1 faculty to 15 students. This fraction that you're setting up that they give you is really a conversion factor. Okay, then we need to set up our proportion using the conversion factor and the information from the problem. So there's our 1 to 15. We don't know how many faculty members they have, but we know they have 675 students. So we're looking for faculty members. We know how many students there are. Next, we need to solve for x. We use cross multiplication to solve for x. Once we cross multiply, we divide by 15. Then our answer is x equals 45. But x equals 45 doesn't tell anybody anything about that word problem. So the last thing we need to do, and it's the most important step, is we have to relate the calculation back to the problem. The math is no good without the understanding of what the math means. So the relationship is there are 45 faculty members at this school. Okay. A rate is a ratio of two quantities with different units. So the most common example of rate is miles per hour. She drove 65 miles per hour. She was driving 55 miles per hour. We were driving in a 35 mile per hour zone. We use it all the time. So we said she's driving 50 miles per hour is the example I gave you. In math, okay, even though this is the sentence we say, in math it looks like 50 miles, the division line means per hour. Okay, 50 miles per hour. So in other problems, the units are canceling out where you're converting from one to the other. In rate problems, you keep both units to establish the relationship between the two units. Okay, so rate problems will start by asking you to find the unit rate. So for example, Takeru Kobayashi of Japan ate 53.5 hot dogs in 12 minutes to win a contest. Find the unit rate in hot dogs per minute, round to the nearest hundredth. Okay, this is an example of a problem that you could figure out how fast was he eating the hot dogs. So the problems are similar to the conversion problems, except now we're looking for the conversion rate. We have a proportion, we have a ratio. He ate 53.5 hot dogs in 12 minutes, but we're basically looking for the conversion rates. We're kind of going backwards. So we start with what they give you as the ratio and set it equal to a conversion rate. Just like before, we cross multiply, and when we do that, we would get 12 times x equals 53.5. Divide both sides by 12. We're keeping both units, okay? So he ate 4.46 hot dogs per minute, okay? So you want to keep both of the units, okay, because it's a rate. So then we relate it back to the problem. Again, it's the most important part. He ate approximately 4.4 hot dogs per minute. Okay, so we can use this as a conversion rate for different times in the future. So if he were continuing to go this rate, how many hot dogs could he eat in 15 minutes? At this rate, how many hot dogs could he eat in 22 minutes? So it just gives you an idea or an approximation of how much he could eat at different times.